Good morning, everybody. Welcome to our continuation of our discussion of concentration. We have been in the land of molarity in our last few conversations. We've also learned how we can talk about solutions according to their density. But now I would like to introduce you to a world that's a little bit bigger than just molarity. So there are many ways that chemists can talk about how concentrated a solution is. And I want to show you those units because different units have different applications. So let's jump in. Going back to our basics here, what is concentration? So recall that concentration in the context of solutions is a relative proportion of solute quantity to either the solution or, in some cases, depending on the unit, solvent quantity. Meaning that it is some kind of ratio of solute to solution. So, for example, in molarity, we had the definition that was moles of solute over liters of solution. This is a proportion that exists between two extensive solution properties, moles of solute to volume solution. So, like zooming out and thinking about what concentration is, it is just like a ratio, a proportion, a relationship that we use to express how much of the solute there's present in solution. So, as we mentioned in kind of like the intro slide, there are many ways that we could express concentration, right? So far, we've used molarity. That's been our focus because when we're in the lab in Chem 210 and in Chem 220, we are looking at some quantity of a solute that we've dissolved in grams, which we can then easily convert to moles using molar mass, and some, not tiny, but like 250, 50, 100, 500 milliliters, which we then convert to liters, volume of solution we're making in our volumetric flasks. And because like those are kind of the scales that we work with when it comes to measuring out solutes and volumes of solutions, molarity is kind of our default concentration unit. However, if those circumstances change, meaning if we're looking at some other kind of scenario where maybe we're not measuring out anywhere between like 10 and 100 or 200 or 1,000 milliliters or like, between 0 and 20 grams of something, then maybe it is a good idea for us to change what kind of concentration unit we use or what way we use to express how concentrated a solution is or how much solute is present. So let's look at the first new concentration unit. This is the unit of molality. Sounds very similar to molarity. You'll see this abbreviated with lowercase m. You'll also see this abbreviated molal, just because, lowercase m is a letter that we use all the time in chemistry. It's kind of, overused almost. So concentration, molality, how is this different from molarity? Let's talk about it. So molality. So this is a concentration unit that expresses a proportion, a ratio between Let's think about this. Molality sounds like moles. So our solute quantity is still going to be in moles here. So concentration unit expressing a proportion between moles of solute. And the proportion that is expressed here is a little bit different. So molarity, right? This was with regard to the entire solution. So when we talk about molarity, we're asking ourselves how many little pieces of the solute, the part, are found in the overall bulk total solution. However, concentration can sometimes be expressed in terms of just solvent, and molality is a prime example of one such concentration unit. So molality expresses a proportion between a quantity of solute in moles to a mass of solvents in kilograms. So molality, mole solute to mass of solvent in kilograms. This probably feels a little foreign to you, which is totally understandable. We are not used to using like massive solution or even massive solvent. We just kind of haven't thought about solutions like that so far. We think about solutions in terms of the total solution and a volume of it. Here, I'm telling you that in molality, we need to look at the mass of the solvent and also the mass of the solvent in kilograms, which is like the physicsy mass unit, right? So let's write down this mathematical proportion. Lowercase m, molality, is equal to a proportion of moles of solute per kilograms of solvent. This is our definition of molality. Emphasis on solvent. It is really easy to get into the habit of just saying it's always per unit solute, or excuse me, solution. Not true. It's always looking at here in molality, solute to solvent. So this is our definition of molality. Okay. So let's ask ourselves, why does this unit exist, right? What's the point? What's the utility in us using the molality unit when we could use the molarity unit? So molality is especially useful when we're trying to figure out how maybe properties of solvent has changed as a result of solute now being present with that solvent in solution. So these are what we call our colligative properties. So let's kind of write down that thought. Molality is useful for when we need to describe solvent changes, meaning how that solvent behaves in solution as a result of a solute being added. So in this kind of circumstance where we're thinking about, well, how is the solvent being changed now that it's present in solution with something that's dissolved? It makes sense that we might want to look at moles of solute to something special about the solvent. So this is where we can relate solute to solvent directly instead of just solute to the entire solution. We have a name for solvent changes in solution as a result of solute being added. This is going to be our kind of like next big topic in this course. This is what we call colligative properties, which you've seen us explore a little bit thus far in lab. So we've got molarity, like idea of concentration, and then we have molality. And in our next video, we will look at some other concentration units where hopefully I can get our slide formatting back. So see you soon.